Okay, so Math 423, complex analysis. We'll start with arithmetic of complex numbers. These are formally defined as ordered pairs of real numbers, but we usually write them as z equals a plus ib, where I squared is -1. The real part is the x-coordinate a, the imaginary part is the y-coordinate b. The imaginary part does not include the I. Two complex numbers are equal if the real and imaginary parts are the same. So that's pretty straightforward. Addition and subtraction, just combine like terms. So z plus w is 2 plus 4 is 6. Plus 3 minus 2 is minus I. Z minus w, 2 minus 4 is minus 2. 3 minus 2 is plus 5i. So just what you'd expect in addition and subtraction. Multiplication should also be familiar if you know FOIL, first, outer, inner, last. You just have to be careful about the I. So z times w here is 2 plus 3i, because that's z, times 4 minus 2i, because that's w. Put a little dot over that I. So 2 times 4 gives me 8. 2 times minus 2i gives me a minus 4i. 3i times 4 gives me a plus 12i. And then 3i times minus 2i gives me a minus 6i squared. So we can combine some of these. Minus 4i plus 12i, that's a plus 8i. Keep in mind that minus 6i squared is minus 6 times minus 1, right? I squared equals -1. So this becomes 8 plus 6 plus 8i equals 14 plus 8i. Great. So addition, subtraction, multiplication, pretty straightforward. Division is a little bit trickier. When we do arithmetic with complex numbers, we want the result to always be in this form, or in exponential form, which we'll see later. So we want it to be in that form. So the problem with division is get the I out of the denominator. And we use complements. So, not complements, sorry. We will use conjugates. So complex conjugate is the same number, but with the sign of the I switched. So z bar, the conjugate of z is 2 minus 3i. The conjugate of w is w bar, that's 4 plus 2i. So it's not the same thing as making the I negative, which sometimes you hear people say. It's switching the sign on the I. So why do we care about conjugates? If you've seen this before, you know that when you multiply conjugates, the inner and the outer terms cancel. So 4 minus 2i is w. 4 plus 2i is w bar. So if I want w times w bar, if I multiply this out, I get 16 plus 8i, that's my outer, minus 8i, that's the inner, minus 4i squared. So these two cancel out. The I squared is a -1. So we get 16 plus 4 is 20. Great. So now we can actually find z over w. Is 2 plus 3i over 4 minus 2i. I want to get that I out of the denominator somehow. So I multiply the top and bottom by 4 plus 2i, because that's the conjugate of the bottom. And what do I get? Well, on the bottom, that's this calculation. Those are 20. On the top, you know the usual FOIL, 8 plus 12i plus 4i plus 6i squared. And now we know that the I squared is a -1. So we get 8 minus 6, that's a 2, plus 16i on the top and 20 on the bottom. And you can split that into 2 over 20 plus I, 16 over 20. And that is, in fact, in A plus IB form. So whenever we do any of the basic arithmetic, you can always get it back into A plus IB form. So real z and imaginary z in terms of z and z bar, usually when you're asked to do things like this. Think of Z as being A plus IB. We just don't know what A and B are. Right? Z bar then is A minus IB. So what is Z plus Z bar? If you just add these two together, right, the imaginary parts cancel out and you just get 2A. And so that's my real part of Z. So the real part of Z is Z plus Z bar over 2. Z minus Z bar now. A minus A is 0, but IB minus IB is 2IB. So what does that tell me? That B, which is the imaginary part of Z, is actually Z minus Z bar over 2I. So we can actually solve for real and imaginary parts in terms of Z and Z bar if we wanted. Pretty much all of the other arithmetic laws that you're familiar with hold for complex numbers: associativity, commutativity, distribution, properties of 1 and 0. We do have to be careful about the various exponential laws, and we'll see that a little bit later. Okay, and then there's the binomial theorem, which looks complicated. This is also written as that, and is sometimes pronounced N choose K. That's what that symbol is. All right, if you remember your probability, this is the number of combinations of size K from a group of size N. But really, when you do this, right, you use Pascal's triangle. So if we want Z plus W to the fourth, we write down Pascal's triangle: 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 1. These are the coefficients. This row is the coefficients for the expansion of this. So what is Z plus W raised to the fourth? My coefficients are 1, 4, 6, 4, 1, and I write it in this way. I'm going to put some plus signs out here because it's just an easy way for me to remember it, right? So I write the coefficients here, and then we start with a Z to the fourth, and we bring that down to Z to the first, Z to the 0th. And then at the bottom, we start with a W to the fourth, W to the third, W to the squared, W1, W to the 0. So what is this? It's 1Z to the fourth plus 4Z cubed W plus 6Z squared W squared plus 4Z W cubed plus W to the fourth. And so that's the expansion. These numbers, 1, 4, 6, 4, 1, those are the combinations from that.